Ladies and gentlemen, let's complete our illustration. We had this project with the A, B, C, D up to H tasks, their precedences, and then the 3-time estimates. I told you about the expected duration and the variance. Expected duration is ED equals A plus 4M plus B over 6, where A is the optimistic time, M the most likely time, and B the pessimistic time. For instance, for activity, if we insert these figures of activity A in the formula, we shall get 10 for A, 17 for M, and 30 for B. So the expected duration, or the average, or mean, is 18. This is the beta distribution mean. The variance for this activity A is sigma squared equals B minus A squared over 36. And this gives us 30 minus 10 squared, which is 20 squared over 36 is 11.11. So, but only the variance along the critical path is required. Variances along the critical path. So the critical activities variances are what we add. By the same process, the expected durations and variances for all the tasks are calculated per this following table. I will do all the calculations. You just try them. You find that you have this expected duration and variance, but we have not known yet the critical path. We shall know the critical path when we draw the network. As of now, we have got expected durations, which we shall fill in the duration box. There you are with your network. I think you are familiar with this one. It runs through from A and B, which are not preceded, up to H. I think by now you know why activity E starts from 56 and not from 27. You are looking at the forward path. 27 is where B ends, but B has to wait until C is completed, since both B and C are inputs give inputs to E. They are predecessors of E. So E cannot start before C and B are completed. Again, you look at H, the same problem. Whereas F completes at 56, after 56 days, it cannot feed into H yet because it has to wait for G to complete at 96, and so 96 will be the start for H, and the end is 100. And then we roll backwards the project, the lower, I mean the latest times are what we shall use to calculate the slack. And this gives us, by now you see what the critical path is, where there is only slack 0, and the total duration is the same as the completion of the project, time completion, which is 100. And so this is S, C, E, G, H. So we shall do some computations. The critical path is SCEGH, where the total variances are 49.11. So our Z is equal to the square root of the total variance, the sum of variance along the critical path, and this is square root of 49.11, which is 7.01. So we want to get the probability that the project is completed between 80 and 100 days to within more than 95 days, in less than 95 days, or not less than 105 but not exceeding 115 days. So this is probability of 80 less than Z less than 100. The probability that the project will be finished between 80 and 110 is the same as, now I want to convert D to Z. D to Z, we use the transformation formula, the Z transformation formula, or we get the Z score. So 80 minus 100 over 7.01 will be less than Z. There is this, that side missing, less than Z, and less than 110 minus 100 over 701. And so shall get probability of Z lying between negative 2.85 and 1.43. For number 2, D greater than, probably that D is greater than 95. The project will be finished in more than 95 days. So the project will take more than 95 days. That probability we can transform now D to Z, and this will be Z greater than 95 minus 100 over 701 equals probability of Z greater than negative 0.71. Then the other one is probability that D is less than 93 days. Again, we convert Z will equal to 93 minus 100 over 701. So the probability that Z is less than negative 1. And lastly, that the probability will lie between, that the project will be finished between 105 and 115 days. Again, we convert this and we get probability of Z lying between 0.71 and 2.14. Yes, determining the probability. I've already given you the probability distribution table. The Z, or the standard normal probability table. And normally it is determined from 0 up to Z. We need the probability from 0 up to Z. So if we get Z, the value of Z, then we can get this probability from 0 up to Z. And we read across the first two figures, but under the last figure. For instance, if Z is equal to 2.85, the first two figures are 2.8. So we read across 2.8 as per that arrow, and then under 0.05. So this will give us 0.4976. So this is the probability from 0 up to 2.85. But then there is the other part before 0. You see this probability curve is bell-shaped and uses the mirror image principle around, so the symmetry is at 0. So less than 0 we have 50%. More than 0 we have also 50%. Now, you know that total sum of total probabilities is 1. So 100%. So at 0, before 0 we have half. After 0 we have half. But now we are reading probability. So from 0 we have that probability, which is 0.5 plus the probability from 0 up to 2.85. From the table we have seen that it is 0.4978. So when you add both probabilities, you get 0.9978. Then the probability that it will be completed within 95 days. So we calculate now for 95, the Z is negative 0.71. So we calculate the probability from, or we know the probability from 0 up to negative infinity, or the probability that z is less than 0 is a half. Now, what we can read from tables is from 0 up to negative 0.71. And from tables, this is the same as 0.2611. So this is not what we want. What we want is shaded, i.e. below negative 0.71. And therefore, we have 1/2 or 0.5 minus 0.2611. This will give us the answer as 0.2389. So you can do practice with that table to read various probabilities for various values of it. So our solutions for 1, 2, 3, and 4, it's important that you draw the graph. That graph does not touch the z-axis. It tends to touch it, but does not touch it, so it is asymptotic to the z-axis or the horizontal axis. So the area is shown, the shaded area is between negative 2.85 and positive 1.43. So you realize then that probability can be broken down into two probabilities, i.e. from negative 2.85 up to 0, and that is 0.4978, and then from 0 up to 1.43, which is 0.4236. So the answer is 0.9241. And then the other area is probability greater than 95. Probability greater than 95 would mean that probability greater than negative 0.71. So the area shaded is to the right of negative 0.71, which means greater than negative 0.71. So again, it has two parts. The part between negative 0.71 and 0, we can read it from the tables, and then the other part is half from, above 0 is half. And then the third is, we wanted a probability below 93. So this probability again is z is less than negative 1. There's a mistake up here. Probability of z less than negative 1. You can read from tables and subtract it from a half, because what you can read from tables is from 0 up to negative 1. But then we are looking at less than, so we shall subtract that shaded area. Then the last one is between the two values on the positive side of the axis. That is 0.71 and 2.14. So we read the probability from 0 up to 0.71. We can also read the probability from 0 up to 2.14. And now we shall subtract the probability for 0.71 from the probability of 2.41. That difference is the shaded area. We shall end here, but you have coursework, and the coursework will be submitted on 11th of April. And these are numbers you already have. I think you're already practicing. It's a project, an exercise on project management. The notes you got earlier there is an exercise separate. It is on a model already. And so I expect you to be practicing. And so I need answers for your coursework number 2 for question 3, 4, and 5. God bless you.